Okay, this is section 5.2, dividing polynomials. And in our textbook, we will be on page 311. So, our objectives are going to be to divide polynomials using long division, and we're going to learn to divide polynomials using synthetic division. The vocabulary is going in this chapter is going to be division, logarithms, and synthetic division. So let's just dive right into it. What is long division? So we learned in lesson 5.1 how to divide a monomial by a monomial using just dividing them out and using exponent properties. Okay, we can use that same skill to divide polynomials by a binomial. So let's look at example 1. It says simplify 6x to the fourth y cubed plus 12x cubed y squared minus 18x squared y all over 3xy. How do we simplify that? Well, we can basically write this, we have fractions, so we can break this apart to say 6x 4y cubed over 3xy plus 12x cubed y squared over 3xy minus 18x squared y over 3xy. So all we have to do is, now we've got three different terms as fractions, and we just simplify and reduce. This is 1, this becomes 2. And then we have 2, x to the fourth divided by x to the 1. Remember, using your quotient rules, 4 minus 1, so it's x cubed. Y cubed divided by y1 is 3 minus 1, so it's y squared. This equals 4. X cubed divided by x is x squared. Y squared divided by y is y. Then we have minus 18 divided by 3 is 6. X squared divided by x is x. And then y, these are the exact same, so they cancel. Anything divided by itself is 1, so it's just 6x. And that's simple, all right? So now we can use a similar process to long division to divide a polynomial by a polynomial with more than one term. The process is known as division logarithm. So they want us to find x squared plus 3x minus 40 divided by x minus 5. So now I have two terms instead of dividing by a monomial, correct? Now, remember, division can be written three different ways. We're going to ignore the fraction way, but we're going to use the box. Remember, this is a dividend, and this is a divisor. The dividend goes inside the box, so we want to make sure it's in degree order. In descending order it is x squared, x to the first, and minus 40. We have to have one of each. So it's x to the second, x to the first, and this is an implied x to the 0. Then this is going to go right here, x minus 5. So how do we do this? So first of all, we take the first term of the dividend, and we divide it by the first term of the divisor. And we get x. That's what's going to go up here. Just like long division, now we're going to take x times x minus 5. We get x squared minus 5x. So remember, when we had long division, we would subtract, but we only had one term. So we put in the negative here. It was always positive numbers that we're dividing. And then this would become negative. Well, we have to subtract this from that. So we have to change all their signs to this opposites. So this becomes negative, and this becomes plus. So now we add them. Anything plus this opposite zeroes out. 3x plus 5x is 8x. Then we bring down the next term, minus 40. Again, we take the first term, 8x, divide it by the first term of the divisor, x, and we get positive 8. So we're going to do plus 8. We're going to multiply this times that, so we get 8x minus 40. But we have to subtract it, and we have to change everything to its opposite. This is 0 plus 0, so we have no remainder, so our answer is x plus 8. So remember, when you take a dividend and divide by a divisor and you get the quotient. How do we check this? We take the quotient times the divisor, and it should equal a dividend. We know how to multiply a binomial by a binomial. We just simply FOIL, right? So that's a long division. Just as with the division of whole numbers, the division of two polynomials may result in a quotient with a remainder. This one didn't have a remainder, but we can. So how do we write the remainder? We take the remainder. If it was 3 plus remainder 2, we would do 3 and 2 over whatever our divisor was. If this is our problem, 3 remainder 2, 2 over 3. We would do the same thing when doing a polynomial. So let's look at another one. Let's do a squared plus 7a minus 11. We want to divide it by, or it says times 3 minus a to the negative 1. What's wrong with that? Well, that's the same thing as saying times 1 over or divided by that. So we're going to do a squared plus 7a minus 11. We've got negative a plus 3. You always want to put your variable first. So now we're going to take a squared divided by negative a, and I get negative a. So negative a is going to go here. Negative a times negative a is positive a squared minus 3a. Now remember, I have to change them all to their opposites. That cancels out. I get 10a. Bring this down, just like you would in log division. Again, I take 10a and divide by negative a, and I get negative 10. So I'm going to have minus 10. Minus 10 times that is positive 10a minus 30. Again, everything changes to its opposite. So this cancels, and negative 11 plus 30 is going to give me what? 19. So I have a remainder of 19. How would I write that? I would say negative a minus 10, because it's positive, plus 19 is my numerator, and then I'm going to get negative a plus 3 in my denominator. Or I can write this 3 minus a. So it'll start off with a negative, right? So that would be my answer. Negative a minus 10 plus 19 over 3 minus a. All right. So now let's look at synthetic division. So that's long division. So basically you just got to make sure that it's in degree order. So let's go over, it's got to be in degree order. And if I had this problem, 3x to the 5th plus 4x squared plus x plus 2, well, I'm missing an x to the 4th and x to the 3rd, right? So 5, 4, 3, 2, 1, and obviously the constant's x to the 0. So I would rewrite this to say 3x to the 5th plus 0x to the 4th plus 0x cubed plus 4x squared plus x plus 2. It must be in degree order, and you cannot skip a degree. So it's got to be in descending order: 5, 4, 3, 2, 1, 0, which is your constant. If you don't have a constant, it's not a big deal, but you have to have a variable in every degree through 1. And if you don't, remember 0 times anything is 0, so technically we didn't add anything. All right, so let's look at what is synthetic division. It's a similar process for dividing a polynomial by a binomial, except for we use our coefficients to do this. So let's get right into the key concept for synthetic division. So first we write the coefficients of the dividend so that the degree of the terms are in descending order. We write the constant r of the divisor, x minus r, in the box. Okay, then we bring the first coefficient down. So let's look at a problem, and then we'll actually do it. So if we want to synthetically divide 2x cubed minus 13x squared plus 26x minus 24, And we want to divide that by x minus 4. So first of all, this is my dividend. Got to know the words. Is it in degree order? 3, 2, 1. Yes. So I take their coefficients. 2, negative 13, 26, negative 24. Then I'm going to do a little box. And I take x minus 4, right? If I equal it to 0, it's really x equal 4. So 4 is going to go here. So you want to say, what is x equal to? So if I took x minus 4 equal to 0, it's x equals 4. So I bring the first coefficient down. Then I do 2 times 8, and I multiply. And I get 8. Now I add minus 13 plus 8 is minus 5. Then I do minus 5 times 4, and I get minus 20. I add here, and I get 6. And I do 6 times 4 is 24. So negative 24 plus 24 is 0. This is my remainder. I don't have a remainder, so this is going to be your constant term. This is going to be x to the first and x to the second. So this is 2x squared minus 5x plus 6 is your answer because there's no remainder. How do we check that? We take this and multiply it by x minus 4 and we should get that. Let's try another one. Okay, so let's practice. Let's use synthetic division and do 2x cubed plus 3x squared minus 4x plus 15. We're going to divide that by x plus 3. So we simply write our box. Is it in degree order? Yes, so it's 2, 3, minus 4, and 15. Since it's x plus 3, I have to equal it to 0. I get x equal negative 3. So negative 3 is going to go here. So the first thing I do is I bring down my first term, 2. Take 2 times 3 is negative 6 and put that right here. 3 minus 6 is minus 3. Minus 3 times minus 3 is positive 9. Minus 4 plus 9 is 5. 5 times negative 3 is negative 15, and that equals 0. So this last thing is your remainder. Since I have a remainder of 0, this is going to be my constant, x to the first, x to the second. So then my answer is 2x squared minus 3x plus 5. There's your answer. That's the quotient of these two things. All right. So let's look at example 5 on page 314. So let's take 3x to the 4th minus 5x cubed plus x squared plus 7x, and we're going to divide that by 3x plus 1. All right, so we rewrite the divisor with the lead coefficient of 1. So this is a divisor. We have to have a lead coefficient of 1, so we can say x plus 1/3. Because if I divide that by 3 and divide that by 3, I get x plus 1/3. Okay? Now, is this in degree order? 4, 3, 2, 1. And I don't have a constant, so I've got 3, negative 5, okay, since I divide this by 3, I have to divide this by 3. So what do we get? We get 1, negative 5/3. I need to make more room for my space here. Okay. 1/3. 7/3. And 0. Since I have a constant, to put a 0 there. Okay, so this becomes what? Negative 1/3. Because when I equal to 0 and I solve for x, I get negative 1/3. So now I can synthetically divide, and I bring down my 1. 1 times that is negative 1/3. 5/3 plus minus 1, negative 5/3 minus 1/3 is negative 6/3, right? Which is actually negative 2. Negative times negative is positive, so we get positive 2/3 here. That equals 3 over 3, or 1. 1 times that is negative 1/3, and we get 6/3. 6/3 times that is going to be negative, and that's 1, 2 equals negative 2/3. 0 minus 2/3 equals negative 2/3. I have nothing else to bring down, so remember, this is my remainder. So this is my constant, x to the first, x to the second, x to the third. That's how you write that. So it's x cubed minus 6/3 x squared plus, this is 1, so x plus 2, and actually this is 2. And then this is minus 2/3 divided by x plus 1/3. All right, and then we can simplify that to make it a little bit more simpler by doing complex fractions, and this actually will result in 2 over 3x plus 1. Okay, I just use complex fractions. All right, so do problems number 2 and number 4, and we will see you in class.